I'm architect Moksha Bhatia and you're watching Urbanism Spinning. Today we are going to discuss about sustainable construction materials. If you are an architect, interior designer, urban designer or an architecture student, you might have heard a lot about what sustainability. And many government policies are also focusing on sustainability these days. But what comes under that? What is sustainability and most importantly, what are sustainable materials? So today we are going to discuss that and let's get started and let me know in the comment section if you have any doubts. What makes a material sustainable? Before discussing specific sustainable building materials, it is important to understand what sustainability actually means in construction. A material is not sustainable simply because it is natural, recycled, or marketed as eco-friendly. Sustainability in construction is measured through the entire life cycle of a material. This life cycle includes raw material extraction, manufacturing energy, transportation distance, installation, maintenance, durability, and end-of-life disposal or reuse. A truly sustainable material has a low embodied carbon footprint, performs efficiently over time, reduces operational energy, and causes minimal environmental harm when it is eventually removed or replaced. In architectural practice, sustainable material selection also depends on climate, building type, availability, and construction systems. A material that works well in one country may not be sustainable in another due to transportation emissions or maintenance requirements. Understanding this life cycle thinking is essential for architects and urban designers who want to design buildings that are genuinely sustainable, not just visually green. So, on number 1 we have engineered wood and mass timber. One of the most important sustainable materials reshaping architecture in 2026 is engineered wood, particularly mass timber systems such as cross-laminated timber, glue-laminated timber, and laminated veneer lumber. Engineered wood is considered sustainable because it is renewable source, stores carbon rather than emitting it, and requires significantly less energy to manufacture compared to concrete and steel. When sourced from responsibly managed forests, timber becomes a powerful tool for carbon-conscious architecture. Mass timber is now being used not only in residential buildings but also in offices, schools, mid-rise commercial buildings, and even urban infrastructure. Countries like Germany, Austria, Canada, and parts of Scandinavia have already mainstreamed mass timber construction. For architects, engineered wood offers structural efficiency, master construction timelines, reduced foundation loads, and high aesthetic quality. However, it also requires strong coordination with fire safety regulations, moisture protection, and acoustic performance. In 2026, architects who understand timber detailing, hybrid structural systems, and timber regulations are high demand globally. On number 2, we have recycled and low carbon concrete. Concrete remains one of the most widely used construction materials in the world, but it is also one of the biggest contributors to global carbon emissions. This makes low carbon and recycled concrete solutions critically important for sustainable construction. Low carbon concrete reduces environmental impact by replacing a portion of cement with supplementary materials such as fly ash, ground granulated blast furnace slag, calcined clay, or recycled aggregates. These alternatives significantly reduce embodied carbon while maintaining structural performance. In urban infrastructure and high-density construction, concrete cannot be eliminated entirely, but it can be optimized. Architects and urban planners increasingly work with structural engineers to specify low-carbon concrete mixes and optimize slab thickness, spans, and structural grids. In 2026, many countries are introducing embodied carbon limits for public projects, making low-carbon concrete not just a choice but a requirement. Architects who understand how material specifications affect carbon metrics gain a strategic advantage in competitions and government projects. So now, on number 3 we have natural and bio-based materials. Natural and bio-based materials such as bamboo, rammed earth, compressed earth blocks, cork, and hempcrete are gaining renewed attention in sustainable architecture. Bamboo is particularly notable due to its rapid growth rate, high tensile strength, and versatility. It is increasingly used in structural systems, facades, and interior elements, especially in tropical and subtropical regions. Rammed earth and compressed earth construction reduce embodied energy by minimizing processing and transportation. These materials also offer excellent thermal mass, improving indoor comfort in hot and dry climates. Hempcrete, made from hemp fibers and lime, is a carbon-negative insulation material that improves indoor air quality and thermal performance. Cork is widely used for flooring and insulation due to its renewability, acoustic properties, and durability. While these materials are not suitable for every project, architects who understand where and how to use them can create regionally responsive, climate appropriate, and environmentally responsible designs. On number 4 we have recycled and upcycled materials. Recycled and upcycled materials play a crucial role in circular construction practices. These include recycled steel, reclaimed wood, recycled glass, plastic composites, and reused building components. Using recycled materials reduces landfill waste, conserves raw resources, and lowers embodied carbon. In interior design and adaptive reuse projects, reclaimed materials also add character and narrative value. Urban designers and planners increasingly promote material reuse at a city scale, encouraging deconstruction rather than demolition. This shift supports a circular economy where buildings become material banks rather than disposable objects. In 2026, architects are expected not only to design new buildings sustainably but also to engage with existing building stock intelligently. So, what is smart material selection for architects? Selecting sustainable materials is not about choosing the greenest option in isolation. It is about integrating materials into a coherent architectural system. Architects must consider climate response, building orientation, passive design strategies, durability, maintenance, cost, and local availability. A well-designed building using conventional materials can sometimes outperform a poorly designed building filled with sustainable products. In professional practice, sustainable material selection should be supported by data, life cycle assessment tools, and performance simulations. BIM and digital workflows now allow architects to evaluate material impact in the design process. In 2026, architects who combine sustainability knowledge with digital tools, technical detailing, and construction understanding are positioned as leaders rather than followers. So, what is future of sustainable materials? Sustainable materials are not a trend. They are redefining the responsibility of architects, interior designers, and urban planners. As climate challenges intensify, material decisions become ethical, technical, and cultural choices. The future of architecture belongs to professionals who understand materials deeply, think systematically, and design with long-term environmental impact in mind. Sustainable construction is no longer about adding green features at the end of a project. It begins at the material level. If you want to grow as an architect in 2026 and beyond, learning sustainable materials is not optional. It is foundational. That was all for today. Thank you for watching. Do let me know in the comment section what you think about it and share it among your friends, and keep watching Urbanism Spinning.
Goodbye.